Hi there. Section 8.2, claims about proportions. So in section 8.1, we set up the claims h sub 1, h sub o. If you didn't watch section 8.1, you definitely need to go back and take a look at that. Then come over here and we'll do claims about proportions. Okay, so proportions means it's a binomial situation. You'll have the sample size, and whatever the situation is, the number of successes. When you divide those two, that's the sample proportion. But then the claim is going to be about the whole population. So if you say, all right, I've got this class of 40 people and 20 of them are male, so 20 out of 40, 50% are male, 50% are female. Now let's use that to see, does that apply to the whole population or the whole school? So the test statistic, if you like to use the formula, is right here, p hat minus p divided by the square root of p, q divided by n. Or you can use the TI-84. And since it is a z, that means that we're using table A2 for the critical values. All right, the first example. So here's Kobe Bryant, just about to shoot the basketball. Do you think he's going to make it? Well, in case you didn't know, Kobe Bryant is retired. So this is his lifetime completion rate. So as a professional basketball player, he made 44.7% of his shots. Now let's compare that to LeBron James. So for the 2017-2018 season, he was with the Cleveland Cavaliers, and he made 857 out of 1,580 shots. I was pretty amazed when I looked that up. 1,580 shots. That's a lot. So anyway, use the 98% confidence level and test the claim that LeBron's completion rate is actually better than Kobe Bryant. So the claim is P is better than, so greater than Kobe's. So you put Kobe's number right here. And then this is saying the percent for LeBron by the time he's retired, his lifetime average, it's going to be better than or bigger than a 0.477. And then H1, since the claim does not have an equals, H1 can stay the same. And the job of H1 is to tell us, is it right-tailed, left-tailed, or two-tails? With the arrow pointing to the right, it's right-tailed. And H sub O always does its own thing and just says equals. Then you write down the sample information, N, X, and when you divide those two, LeBron's success rate is actually 54.2%. So that does look like it's better than Kobe, but is 1,580 shots enough to actually prove LeBron is better than Kobe? So since it's a right-tailed test, then, hey, back up a second, then you put 2% on the right tail, 98% on the left side, and then get table A2. Now we're ready for that. And because we're looking at the left side has 0.98. So look through here until you find what's closest to 0.98, and it's right here at 97.98. So if you go to the left, the critical value will be 2.0, and if you go to the top, it's going to be 2.05. So write that down, put it on the pretty little picture. Critical value is 2.05. And you could write out the word critical value. I prefer to just abbreviate it and put CV, critical value. And then use the calculator. So go to Stat, Tests, and then one proportion, Z-test. Next, this right here says P0. So that's saying when you look at H sub O, what does P equal? So that'll always be the number from the claim, 0.447. Then you type in what is X and what is N. Now, I have the habit of putting, when I write it down, I write N first because I think of it, okay, he did 1,580 shots first, then did he complete them? So when you go to the calculator, it has the smaller number first and then the bigger number. And then this should be pointing to the right, so the calculator knows it's right-tailed, and then go down to calculate, and it will look like this. So this is the H1. Then it says Z equals 7.628. And if you're asked for the p-value, that's this. And the p-value in this case would be 0.000000000001207. And the p-value means when you make a conclusion and you say, yes, LeBron is better than Kobe. The p-value is the chances that you're wrong. So that would be 0.0000000001207 chance I'm wrong. So I can be pretty confident that LeBron James is better than Kobe Bryant. Okay, but we're using the test statistic. So you write that down. Test statistic, there we go, 7.6. Done with the calculator. And then show where that lands on the picture. And that lands to the right. And it lands pretty far past a 2.05. So that means reject H sub O. And reject H sub O is basically the official way to say, yay, I proved something. So what you're doing is actually saying, reject this equal sign over here. Are the two players equal? No, reject that. So the claim is actually true. LeBron is actually better than Kobe when it comes to making shots in basketball. Next up, leaving the game of basketball, how about the Giants, San Francisco Giants? Test the claim, they will win at least 50% of their games. So at this point in the season, the Giants have won 41 out of 85. That's not quite 50%, unfortunately. Anyway, the word at least means bigger than or equal to. So the claim has bigger than or equal to 50%, but use the decimal form, 0.50. And since the claim has an equals, H1 needs to be the opposite. So that makes it a left-tailed test. And H sub O just has equals. Then write down the information. This time I decided to put it the way the calculator does, putting the X first and then the N. And when you divide those, you see that they have won 48.2%. That doesn't quite look like it's going to be at least 50%. But let's see what the stats say. So first of all, look up the critical value. And let me back up a second. Notice in this one, I just said test the claim. I didn't say what level of confidence to use. So whenever that is left out, then use 95% as a default. So we'll be using 95%. Okay, so since this is a left-tailed test, I'm looking on the negative z-score, and if this is 95%, then this is 5%. So look for 5%, and right in here, there's a tie between 0505 and 0495, and that little star is saying, look at the bottom of the page, and if you were looking for 0.05, then use the critical value negative 1.645. So draw the picture, put critical value equals negative 1.645, and then for extra fun, let's do the formula. So the formula says take the p hat minus p, then this would be p and q, since p is 50%, q is 50%, and that's out of 85 baseball games. And then the test statistic is only a negative 0.3. So right here would be 0 in the middle. Negative 0.3 would be a little bit to the left, but it definitely does not go past 1.645. And when it lands in this blank region right here, that means we did not prove anything. Didn't prove it's true, didn't prove it's false, just no conclusion. The official way to say that is failed to reject, or in other words, we did not prove anything, and you could say it that way also. Okay, then on to the last example. This one used 95% level of confidence, and then test the claim less than 40% of science and engineering graduates are female. So the data that I found was in 2015, 360,851 graduates, and 125,092 were female. So the claim is less than 40%. So here's the claim. Since the claim doesn't have an equals, then H1 can stay the same, meaning it's a left-tailed test. H sub O has equals. Since we're using 95%, that means alpha equals 0.05. Write down the data, divide the two, the small number divided by the big number. So actually, based on 2015, it was 34.7% of the graduates were female. Then since it's a left-tailed test, we'll be using, it's actually going to be the same as the last example because this is going to be left-tailed and 0.05, so that's going to be right here in the middle. Again, use negative 1.645. Then draw a pretty little picture, write down the critical value, and then let's use the calculator. Okay, so I switched up and used my old calculator. So go to tests, one proportion z-test, and then again, this part is saying what's the number in the claim, 0.4 or 0.40. Then type in the x and the n, and then right here it says calculate. And z is equal to a negative 65.407. We definitely proved something there. So a negative 65.407, does it go past negative 1.6? It would land way, 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 way over to the left. That means yes, we definitely did prove something. And the claim said it was going to be less than 40%. This, yep, that's less than 40%. Also, when this lands to the left of the critical value, that means that the less than is true because it's landing to the left. All right, so that's it. I hope to see you again soon.